Okay, now let's us go to the next step. Okay, now we are in a vector operation. I think you all have learned this during foundation. Okay, for example, this vector A shows upwards. If it is opposite of the one that you draw at the first place, it would be negative. Negative vector A. And then if you multiply the vector A 2 times, the magnitude will be longer, which is double. So it will be 2A. In this situation, if the vector A is 1.5, but the direction is opposite, so you need to write it as negative 1.5A. And then for this, the last one, it is half of the vector A, so it will be 0.5A. Is it clear now? Okay, this one is simple. I'm sure you all know. So I will go to the next page. Okay. Have you all know the parallelogram law and the triangle construction? Have you all familiar with this? Okay, good. If you're all familiar, then it is much easier for me. Okay. Okay, for parallelogram, okay, first we will look at this one is vector A and then vector B. What is the meaning of the parallel? Parallel, which means the vector is at the same side, right? For example, you can see here, vector A is parallel to this side. Okay, for vector B is parallel to at this side. So that's why you draw it like a rectangular shape, right? Okay, if you want to find the resultant force or the summation of A and B, it is equal to from the end point, the start point until end point here. So this is the total vector where A plus B. A for triangle, the shape is in a triangle, which is this one for vector A and then vector B. The total A plus B would be from the start point of A until the end point of B. So this is the vector A plus B. It can be another shape at the bottom. Either you move the vector A to this point, which is at the end of the B. It also equals to B plus A. Because you start with B, then you end with A, so B plus A is like this shape. If you start with A and then A plus B, it will end at point B. So for collinear case, which is in the straight or side by side, the vector A and B, so if you want to find the summation, so the vector A plus vector B, it would be straight line. This one for collinear case, or the vector side by side. Okay, is it clear until now? Make sure you know the basic first. Okay, now let us go to the next point. Okay, for subtraction. Okay, just now, Just now is on addition. Now we will look at the subtraction. This one vector A, and then another one vector B. So there's a two vector here. You want to look at the subtraction, which is A minus B. If the question is on A minus B, but you have A plus A and plus B, right? There's no minus. So how you want to do it? You elaborate the question into A plus minus B. Okay, so A is still positive. And then this B, you need to change the direction. So the direction would be the opposite. So the arrow would be like this. Okay, what is the difference between R and R prime? Okay, just now, for addition, the symbol is R. And then for subtraction, the symbol is R prime. Okay, the prime were signed because the prime were signed here because it want to show you the difference between addition and subtraction. Yeah, it is just the image. You want to show you the difference. If I write it as R as well, you cannot you want to see, tell you clearly, this one is for subtraction. Okay, this one is for addition. You just want to show you the different addition and subtraction. Actually, it is the same. It is the total. Okay. We just want to show you the difference between addition and subtraction. If in real situation, it is not named as R or R prime. In real situation, it would be FR or FT. You can name it. You can label anything. F what? FA in real situation. This one, it is just a display. You want to show the difference. Okay. Now let me continue. Okay. Now let me continue. This one is a parallelogram shape. Okay, where you can draw it like this. The R prime is at the start of point A and B minus. And then for triangle, you just move the B minus B on top so that you will get the triangle shape. Okay, for when can do you need to go to men's room? You can go, so you don't need to wait for me. You can drink and have a rest while you listen to the lecture. Ah, you cannot see? Why is it? Um, okay. Okay, let me take your comment and then I will go through the ITMS. So I have to wait for their feedback. Why is it you all cannot see the one the draw on the. Okay, for now, try to. Okay, for now, try to rejoin. You need to log out and rejoin. Make sure you clear all the link that you have opened before, because your name cannot be double what you call it, double listed. If your name is double listed, then the traffic will high, and then it will keep on rejecting any 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 what do you call that, any rejoin or any, the system will jam lah. So please try to clear all the cache. Okay, I will wait for 30 seconds and then I will continue so that you all can join in the class. Okay, now let me continue. Okay, now it is on the vector operation. Okay, just now you all know where to draw the R, or the resultant force. The resultant force is the final force. So when you draw the head of the resultant force R here, the start is at this point. You need to draw the line which is A and B. It shows you the component. It is side of the parallelogram. Okay, this one is the component. Okay, now, okay, for example, where there's three forces, which is F1, F2, and F3. If you can see here, there's a lot of forces at point O. To make it easier, that's why you need to know the component. Usually it is much easier when there's a two component. That's why you need to draw two component. So when there's a lot of forces, so you can make it as a, if you want to find the FR, FR is equal to F1 plus F2 plus F3, right? But you need to make it easier into two components. So you need to create another force, which is the combination of F1 and F2. So when you plus F1 and F2, you will get this direction, this force, so that you will only have two components at this point and another one this point. So it is much easier. So at the end, you can find the resultant force. Is it clear? Okay, now we will go next. Okay, for example, this screen. Okay, after this, we will look how to apply the angle in certain situation. Okay, for example, this one, there's a three forces here, FA, FB, and FC. So how we want to find the FR? Later we will look. Okay, there's a two procedure, which is the parallel and then the trigonal. So for sure, you all know what is the law of cosine and law of sine. You have learned during foundation. So for law of cosine, it will show you the magnitude. And then for sine, is the direction. Direction is the theta. And then the magnitude is the Newton, the magnitude at this point until this point. What are the forces value, which is the Newton? This one for cosine. Then for law of sine, we will show you the direction, which is in theta. Okay, now we will look. Okay, what is the parallel, the procedure on parallelogram law? First, you need to sketch or draw where the vector show you in a parallel shape. Okay, make sure there's a two component like just now that I show you, right? Make sure there's a two components so that it is much easier to find the angle and then the direction. And third one, if the force is to be resolved into component along the two axes from the tail of the force, then you need to start at the head of the force. So then you need to construct the parallel line. Okay, lastly, you need to label all the unknown and unknown magnitude and the angle. Lastly, you need to do the calculation. So these are the 4 steps to use the parallelogram law analysis. It is quite blur right now because you have not tried it during the in real situation. Later we will look at the question so that you can know it is much easier. If you read like this one by one, I'm sure you all not know how to use it. Okay, this one is a sine law. You all know, I'm sure, during the secondary school, A over sine theta, if you want to find A, the magnitude, you want to find A, you need need to have the theta at A here, or you want to find B, or you want to find C, you can use this formula. Make sure one or two value is known. And then if you want to find the angle, okay, I'm sorry, it's not for angle. Either you can find the angle or the magnitude, you can use the cosine law. Okay, make sure you memorize this formula. Later will be used. It is the trigonometry law. Okay, now we look at the trigonometry law. First, you need to redraw a half portion because it is in trigonometry. So make sure, of course, it will be triangle, right? And then you can find the magnitude, which is, for example, this one, this magnitude here, you can find using the law of cosinus. If you want to find the direction, right. Okay, now, do we have time? We should end another 3 minutes. I think I should proceed it until 11:50. So I will show you example one. Okay, this one, you need to determine the magnitude of the resultant force F1 and F2 and its direction. Okay, make sure you measure counterclockwise. So counterclockwise is at this direction from the positive x-axis. So this part bottom here is the positive x-axis. So this one is x, y, positive. For x, this one positive. So at this point, you need to find the direction at this point. So how you want to find the FR and F2? What the first thing you need to do? Refer back to the procedure. Okay, refer back to the procedure. You need to draw. First thing you need to draw. Okay, how you want to draw it? Okay, how you want to draw it? Okay, first, you need to draw back. Okay, this one X, and X, X and Y, right? So you draw back the force. Can you see the the figure. No. Hmm. Okay. I think I will continue tomorrow. Tomorrow night during our replacement class. We are using MST. So I will start with this example one. Tomorrow night, replacement class. Okay. Okay, we need to stop now before the traffic jam. In each class, before and after 10 minutes, we need to log in and log out. So see you tomorrow night. Okay, bye. Yeah, thank you. You're welcome. Bye bye. See you tomorrow night. Bye bye.